Good morning, students. Today's topic in physics is Brownian motion. So there are very important concepts in this topic. So concentrate yourself. We are going to start. Brownian motion. The existence of the molecules in continuous random motion can be demonstrated by Brownian motion. In experimental setup below, a microscope is used to look into a smoke cell which contains some smoke particles as well as air molecules not seen by the naked eye. And here is a setup. This is the box containing smoke and air particles as well. Here will be a light source that will put light on the particles. Here is a microscope, and this is the eye which will look into the box. Observation. In bright light, smoke particles show up as bright spots which move in a continuous and jerky random motion. Explanation. Smoke particles are fluid which flow or move freely. Air molecules, being much smaller than the smoke particles, can easily collide with them. When bombarded by an air molecule, a smoke particle is forced to change its direction of the motion. Because smoke particles are continually bombarded on different sides by air molecules, they are seen moving in a random zigzag path. Like this. This is a rough sketch of the movement of the smoke particles. Conclusion. The random motion of the smoke particles in air is known as Brownian motion. The movement of the smoke particles is due to their random collisions with the air molecules. It predicts that the molecules are moving randomly. Note, this is very important tip. Do not mix the nature of the Brownian motion with the cause of the Brownian motion. Brownian motion is the random and irregular motion of the tiny particles such as smoke or pollen grains, not the motion of the fast moving air molecules. So this is very important point. The Brownian motion is actually the motion of the smoke particles, not of the air molecules that bombarded the tiny particles. Exam tip. It is a common mistake for students to think that the random movements are due to the collision between the smoke particles. This is due to the collision between the air and smoke particles. So two very important points are here. Brownian motion is not actually the movement of the air particles. This is the movement of the smoke particles. And second very important point is Brownian motion is not caused by the collision of the smoke particles with each other. This is actually caused by the bombardment of the air molecules with the smoke particles. So, these are very important points. Note, the idea that particles are in constant random motion explains why the smell of the aromatherapy scents spreads quickly. Do you know how does scent travel so far? We are able to smell because our nose picks up something in the air which excites the sensory cells. Similarly, the male emperor moth has very powerful sensory cells in its antenna that detect scents from a distance of 10 kilometers away. This tells us that scents are actually particles that float or drift about in the air. These tiny particles move about in random and haphazard manner, that is Brownian motion, as they spread through the air. The female emperor moth releases scents when it is ready to mate. A single scent particle is sufficient to set the male moth on a journey to find the female moth. He must hurry through because the first male to arrive has the best chance to mate. Using the kinetic model of the matter, we know that air molecules will move faster and bump into one another more often when temperature rises. This rapid motion helps spread the scent particles faster. Hence, on a hot day, male emperor moths are able to pick up scents faster and over a long distance, and are thus more successful in tracking female emperor moths. So the point is here, in hot weather, normally the temperature rises, and when the temperature of the molecules rises, they move about more faster. That's why the scent spread in summer more rapidly as compared to winter. Here is a question. Brownian motion of the smoke particles can be studied by using the apparatus shown below. Here is a apparatus. This is a cell containing smoke particles and air particles. Here is a light source. Here is a microscope through which an eye can see into the box. What causes the Brownian motion? So we have studied it earlier. The Brownian motion is caused by the bombardment of the air particles with the smoke particles. So this should be the answer. And the answer here is C part, that is random collision between the air molecules and smoke particles. Now we will see why not A, B and D are correct. The A option is convection current in the air. This is not right. B, heat from the lamp. This is not right. D, random collision between the smoke particles and the other smoke particles. This is a common error, not right. So C option is the answer. The zigzag motion of the smoke particle is due to the random motion of the air molecules which collide with smoke particles. Here is another question. Brownian motion provides evidence that C part is the answer. Air molecules are in continuous random motion. So this is the evidence. So now we will see A, B and D options. A option is smoke particles consist of the molecules. B option is smoke particles are lighter than air molecules. And D option is air molecules attract smoke particles. So C option is right. Air molecules are in continuous random motion. Actually, this is the evidence of the Brownian motion. Here is another question. So here are some options. Brownian motion is observed by observing smoke particles under a microscope. Which of the following statement are correct? So option 1 and 2 are right. Here is 1. So actually this is only 1 and 2 are right. C option. So 1 is smoke particles are move about in random manner. This is right for Brownian motion. And 2, the motion is caused by the air molecules colliding with the smoke particles. This is also right for the Brownian motion. And 3rd is if larger smoke particles were used to Brownian motion would become more rapid. 3rd option is not right because when larger smoke particles will be used, Brownian motion will get slow, not rapid. So C option is right, that is 1 and 2 only. Larger smoke particles would show less rapid motion. They are more massive than small particles and are therefore accelerated less for a given force. Next question is, which of the following statement is correct for Brownian motion? C option is right, that is, smoke particles will be observed to slow down if the air temperature drops, because the movement of the particles is directly related to the temperature. More the temperature, rapid will be the movement of the particles. Less the temperature, slow will be the movement of the particles. So C option is, smoke particles will be observed to slow down if the air temperature drops. So now we will see why A, B and D options are not correct. A option is, it applies strictly to gases only. No, this applies to fluid, that is liquid and gases. So that's why A option is not right. B option is, smoke particles in air in a Brownian motion experiment can be observed to dance in a regular, predictable fashion. Their motion is not regular and their motion is unpredictable. D option is, the motion of the smoke particle in the air is due to the smoke particles colliding with each other. The Brownian motion is not because of the smoke particles colliding with each other. This is actually the movement because of the bombardment of the air molecules with the smoke particles. Here is another question. The phenomena of the Brownian motion shows that B option is right, that is, molecules move about randomly at high speed. A option is, molecules exist and can be seen as bright dots moving about molecules. So here is not given smoke particles, so that's why A option is not right. C option is, smoke particles behave as molecules. They behave as molecule, but this is not right. D option is, smoke particles can be used as models of the air molecules. Only B is the right, molecules move about randomly at high speed. Another question is here, that is, in Brownian motion experiment, the tiny smoke particles are observed to move in a random zigzag fashion. This is due to, C option is right, that is, uneven bombardment of the air molecules on the smoke particles. The option is, the smoke particles being very light. Wrong. B option is, convection current of the air. Wrong. D option is, tiny smoke particles tend to settle down in a zigzag fashion. Wrong. Conduction of the heat. Wrong. C option is very right, uneven bombardment of the air molecules on the smoke particles. So make your concept very strong. The Brownian motion is actually because of the bombardment of the air molecules on the smoke particles. This is the original concept of the Brownian motion. So when you have your concept very clear, the option will be very easy to tick for you. Another question is here, when the Brownian motion of the smoke particles in air is observed with microscope, moving points of the light are seen. These points of the light are reflections from. B option is right, that is, smoke particles only, moving randomly. So this is the concept. Because air molecules are not seen, only smoke particles can be seen when moving, when seen through the microscope into the cell that is having smoke particles and air particles. So this is the answer. The air particles are too tiny to be observed, and so the light spots come only from the smoke particles. The smoke particles are moving freely but not vibrating. A option is, air particles only. This is wrong. Smoke particles can be seen. C option is, smoke particles only, vibrating. D option is, both smoke and air particles moving randomly. Wrong. B option is the right, smoke particles only, moving randomly, not vibrating. Exam tip: light source is placed at the side so that the light rays are reflected by the smoke particles and received by the observer through the microscope. So this was the lecture. Read it again very carefully and make your notes. Thank you so much.